Next one is 4-bit serial in parallel out shift register. So in this register we are entering the data into the register serially, that is one after the another, bit by bit, and we are taking the output in the parallel form, all the bits at a time, right? In the previous register you have taken output serially and you have loaded data serially. So these are the 4 flip-flops. The output of each flip-flop is connected to input of next flip-flop. So you can represent like this also. This is, we call this as symbol or block diagram. I am explaining to you about serial in, serial out, shift right, because I have not given the symbol for the previous register. So you just see. So this is the serial input available, right? And the data is shifted one bit to the right side, and serial out. This is the data transmission technique in case of serial in, serial out, shift right, shift register. The logic symbol for this will be this one, serial input, serial output. Both are same, right? So shift left, if you take shift left, you will get serial output here, serial out, you will apply serial input here, serial output, SISO, shift left. In terms of block diagram representation, you can use these symbols. The meaning of this is the output of this flip-flop is connected to input of next flip-flop. The output of this flip-flop is connected to input of next flip-flop. Next, you can take this as logic symbol or block diagram for serial input and serial out, shift right, shift left. Now let us see the same technique for this type of shift register. So there are four flip-flops in this. So I will take 4 flip-flops. Serial input, whatever the input you want to apply, here you have the terminal. Next, serial input, all the 4 bits are loaded and they are taken in parallel form. All the outputs are taken in parallel form, that is output in parallel form, input, serial input, so parallel output. You are taking all the outputs for the single clock pulse. For the single clock pulse, all the outputs are retrieved. For the 4 clock pulses, all the inputs are loaded into the register. This is the symbol of this one. Or data transmission technique. We call this as data transmission technique. Data transmission in this type of register is like this. And if you look at the symbol, serial input, parallel output. Parallel out, serial in. So serial in, parallel out, shift register. SR stands for shift register. So this is block diagram representation. right? Now let us see the actual circuit. So as it is a 4-bit, we require 4 flip-flops. I will take 4 flip-flops. You can choose the flip-flop of your own choice if they have not mentioned to design this register using particular flip-flop, right? So as D flip-flop is simple in operation, I will choose D flip-flop. So this is D1, D flip-flop 1, clock pulse, Q1, Q1 complement, D2, this is D flip-flop 2, clock, Q2, Q2 complement, D3, clock, D flip-flop 3, Q3, Q3 complement, D4, Q4, D flip-flop 4, clock, Q4 complement. In order to load the data serially, you have only one terminal. What I will do is I will connect serial input here, and the output of each flip-flop is connected to the input of next flip-flop, right? And I will connect the clock pulses. Positive going edge, all the inputs for first 4 clock pulses of positive going edge, all the 4 inputs are loaded into these flip-flops. Next, here I am taking the outputs. This is Q1 in parallel form, Q2, Q3, Q4. So this is complemented output, right? These are the outputs in, that is parallel out, parallel out. So what happens for this? After designing the register, if you want to clear all the outputs of the flip-flops, you can add clear input. You can activate this input. You can connect this input. CLR. CLR complement. So by enabling this, the contents of this register is cleared to 0, right? So this is block diagram, logic symbol, you can call this as symbol, logic symbol. This is logic circuit, this one, logic circuit. This is data transmission technique, how the data is transmitted in this. So first of all, the 4 inputs are loaded to the 4 flip-flops, one after the another, bit by bit, and for the next clock pulse you can retrieve all the bits at a time. So you are entering the data, you are loading the data into the register serially, bit by bit. You are retrieving the data, all the bits at a time. For the first, initially the register content is cleared by enabling clear complement. Next, for first 4 clock pulses, 4 bits of data is loaded in 4 flip-flops bit by bit, right? 4 bits of data is loaded and shifted in 4 flip-flop bit by bit. For the single clock pulse, all the 4 bits can be retrieved. So for the positive, only for single positive going edge of the clock pulse, you can retrieve all the outputs at a time. Means you are retrieving all the outputs in parallel form. So that is serial in, 4-bit serial in, parallel out, shift register. So let us see the next one, parallel in, parallel out. Four-bit parallel in, parallel out, shift register. So the data transmission technique in this is, you are entering the data, all the bits at a time. Parallel in, you are retrieving all the bits of data from the register at a time by using a single clock pulse, right? So the logic symbol is this one, parallel in, parallel out. You have a clock pulse, you are retrieving, this is parallel input, this is parallel out, right? This is logic symbol, this is data transmission technique. This one. Now let's come to the logic circuit. So simply what I will do here is, I will apply the inputs parallelly. So I have designed 4-bit parallel in, parallel out shift register using D flip-flops. So this is input D1, D2, D3, D4. So I am loading all the bits at a time. For a single clock pulse, initially the content of the register is cleared by enabling this clear complement, right? So I will erase and I will write the matter. It's very simple. You copy this. Have you copied this? So initially the register content is cleared by activating asynchronous input. Next, for a single clock pulse, whenever the positive edge of the clock pulse arrives, all the inputs are loaded into the flip-flops. 4 bits of data is loaded into 4 flip-flops. For a single clock pulse, 4 bits of data is retrieved from 4 flip-flops. If you draw the logic symbols and the logic circuit, and if you just write these 2 points, you will get full marks. If this question is asked for 10 marks, you will get 10 out of 10, right? So this is parallel input. You are loading all the bits at a time. For a single clock pulse, all the bits are loaded into the 4 flip-flops. You are retrieving all the bits at a time, parallel out. So this is parallel in, right? So parallel in, parallel out, shift register.